Well, hello, friends. We are back for another example of determining linear, quadratic, exponential, or neither. And this is, again, looking at tables. We looked at tables last week. We're going to look at tables again this week. This is on page 58 of your pink book. And again, if you can't find your pink book, I have attached the Word document to this assignment. And so you are welcome to open that up and follow along with me. You could put your answers on a separate sheet of paper if you don't have your pink book. So there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 tables on this page. And so we will look at 3 of them together, and that will leave the other 7 for you to do on your own. Probably we will just look at these first 3 right across the top. Again, we are looking at linear, quadratic, exponential, or neither. And in our first example, we were considering those functions from an equation. And so now we're going to look, again, we looked at this last week, of considering these types of functions from tables. So why don't we take a look at this first example right here. And as we look at this example, we see that the x values are increasing. And each time, as we go down the x column, it appears that they're increasing by 1. And plus 1, and plus 1, and plus 1. We learned that linear equations have the same rate of change, or the same first differences. Quadratic functions have the same second differences. Exponential functions, when you find their first difference, it almost is a repeat of the column. And then when you find the second difference, it's still almost a repeat of the column. It is growing or decreasing by a constant multiplier. In fact, if you go down the y column, you don't add or subtract the same thing. You end up multiplying by the same thing. So keep that in mind as we are looking at these problems. So first of all, we're going to check for first differences every single time. Are we add or subtracting the same thing? So let's look. From -7 to -5. Well, that's increasing by 2. From -5 to -3. Plus 2. From -3 to -1, and from -1 to +1. Well, look, the first differences are the same. So if the first differences, or the rate of change every single time, is 2 over 1, 2 over 1, 2 over 1, this example is linear. It has the same first differences. And in fact, what is that? The slope, or the first difference, is 2 over 1, or 2. Change in y over change in x, first difference. This second example, okay, let's look at it. What is the x column doing? -2 to -1, -1 to 0, 0 to 1, 1 to 2. Well, the x column is changing by 1 each time. Let's look at the y column. Let's decide if it has the same first difference. So what do we notice? From 4 to 1, that is subtracting 3. From 1 to 0, that's not subtracting 3. What does that tell us? Well, right away it tells us it's not linear. Well, let's continue with the first difference. From 1 to 0 is -1. And then, look at there. It was coming down, and now it appears to be going back up. That could be a sign of what type of function? Think. From 0 to 1 is +1. From 1 to 4 is +3. All right, look at these first differences. They are not the same. It is not linear. Well, let's see about the second differences. So that was first difference. And now let's check second. From -3 to -1 is, I'm increasing 2 right here, aren't I? From -1 to +1, I'm increasing 2. From 1 to 3, I'm increasing 2. So what do we notice? Well, the first differences are not the same, but the second differences are the same. Which type of function has the same second differences? That's right, quadratic. Visualize what's happening. X is increasing by 1. Y is doing what? Going down, coming back up, coming back up. In fact, right here at 0, 0, this would be the vertex. This would be a parabola that opens up, just like that, okay? How do we know it's quadratic? From a table, it has the same second difference. So we would need to write that down somewhere. Same second difference. Okay. Any table that has the same first differences is linear, either adding or subtracting the same thing. Any table that has the same second differences, adding or subtracting the same thing the second time through, what's the difference between the slopes, is quadratic. Okay, let's look at the third table. What do we notice? Well, we notice the x values are increasing by 1 again. Okay. Each time, +1. What are the y values doing? Oh, man. 0.111 to 0.333. When I subtract those, you know what we get? 0.222. Okay. From 0.333 to 1. When I subtract those, you know what we get? 0.667. From 1 to 3, that's a difference of 2. From 3 to 9, that's a difference of 6. All those numbers are different, aren't they? Those are the first differences. They are not the same. So what does that mean? It's not linear. Okay? Some of you may have an idea what this is. Let's keep testing. So that's the first difference. All right, it's not linear. Let's test the second difference. The difference between 0.222 and 0.667 is 0.445. Okay. From 0.667 to 2, that's not 0.445. Let's see what that is. 2 minus 0.667. And you know what it is? 1.333. And then from 2 to 6, that's 4. My first differences are not the same. My second differences are not the same. What does that mean? It's not linear. It's not quadratic. It might be exponential. Let's see. It's not automatically exponential. What makes it exponential? Well, it's either completely increasing or completely decreasing. There's no change in direction. And y values increase by multiplying. So instead of adding, let's go back. Is there another way to get from here to here? Is there another way to get from here to here? How about from 1 to 3? How about from 3 to 9? Mhm. How do we get down the y column? Multiply. Can you tell what we're multiplying by? 3. 0.111 times 3 is 0.333. 0.333 times 3 is almost 1. Technically, it is. 1 times 3 is 3. 3 times 3 is 9. So this function is exponential. Why? Because we're multiplying our constant multiple down the y column by 3. And if you weren't sure, what is 9 divided by 3? Oh, yeah. What's 3 divided by 1? What's 1 divided by 0.3 repeating? What's 0.3 repeating divided by 0.1 repeating? Multiplying by 3. Okay, I am confident that you can get the rest of these. There are 7 left. And so here's what I need you to do. Once you have completed page 57 and 58, if you would just scan that, you can upload it to Google Classroom on the red tab and make sure you mark is done. And we'll be back together on Wednesday. We'll do a little more practice, and then we'll have a quiz over this on Thursday. So I'm confident that you're going to do well. Keep working, keep trying, keep thinking. We're going to get through this, sweet peas. We are the mighty Irish, and we can get through this together. So hang on. All right? Love you. Good to see you again.